this machine just may suck the life out of global warming. One scientist wants to stop climate change by vacuuming greenhouse gases from our atmosphere. A daring geoengineering strategy envisions thousands of carbon scrubbers, battling one of humanity's greatest threats. But is this plan a blueprint for survival?
We're turning it on!
Or disaster?
This thing's collapsing.
To find out, a special team travels the world and explores the depths in search of answers. At normal levels, carbon dioxide helps trap the heat of our sun in the atmosphere. Without it, the Earth would suffer another ice age. But now, the balance is tipping the other way. The Earth is heating up, with no end in sight. Every day, we pump millions of tons of carbon dioxide into the air, and it's changing our climate.
The amount of climate change we've seen in the last 30 years is tiny. It's like 0.1 degrees or 0.2 degrees. We're worried about 5 degrees.
A change that big means 100 million people could lose their homes to flooding, and crop failures may expose entire countries to starvation, unless we can lower carbon dioxide levels in time. Professor David Keith travels the world searching for a way to extract CO2 from the atmosphere. Now he thinks he's found a solution. He wants to remove excess carbon dioxide by geoengineering the air we breathe.
What we're doing is talking about capturing CO2 from the atmosphere and doing that for the first time in history at industrial scale.
Professor Keith wants to clean excess carbon dioxide from our air using thousands of huge machines. They would run air through a series of chemical filters that would capture much of the CO2, then return the cleaned air to the atmosphere.
In the long run, what we'd like to do is build something that captures 1 million tons a year of CO2, disposing of CO2 that would otherwise be vented to the atmosphere.
David Keith wants to test his strategy with a fully operational carbon scrubber prototype. The Discovery team is going to help him do it.
The risk is that you're not pulling enough out of the air for the amount of energy you're using.
Eco-engineer Jennifer Langwell will look at the mechanics of the problem.
I'd like to fire it up personally.
Physicist Basil Singer will help design experiments.
Whoa! That went seriously quickly.
And multimillionaire businessman Kevin O'Leary will plan the logistics.
At the end of the day, can we make money doing this?
It's easy to design a system to scrub all the CO2 out of the air, but the typical systems require an enormous amount of energy to do that, and that costs money.
Does it matter where you put it?
No, that's the big magic. The advantage of air capture is you can essentially do it anywhere.
The team faced two major challenges. First, help create a working, cost-effective scrubber. Second, find a way to safely store the billions of tons of CO2 that the scrubbers would remove from the air. With carbon emissions growing by the day, Dr. Keith believes it's time for action.
The idea that we can't do anything is just nonsense, and it's pernicious nonsense, because it gets people away from actually moving forward. That's like saying you're worried about your house is burning down. You're going to wait till it actually gets much hotter in your room until you do something. If you know that your house is made of wood and you can see that a fire started and you know the physics that says the fire is going to keep burning, you should get worried long before your room gets hot.
For the first experiment, Jen goes to Corunna, Michigan, where construction of the first prototype carbon scrubber is underway.
Every process has a challenge when you go from paper and theory to reality, and I think this is no different. It's never been done before. My concern is that when we do scale this up, we're not going to see the numbers that we're seeing on paper.
Dr. Frank Zeman has worked on the technology for more than a decade. He believes the scrubber concept is now ready to leave the drawing board. The scrubber relies on a simple chemical, sodium hydroxide, or as it's more commonly known, caustic soda. Zeeman places a small sensor in a jar of it to show how fast the soda absorbs CO2.
Very quickly dropping.
Very quick.
Almost immediately, the level drops significantly.
Outside, 385 parts per million is pretty standard, but we're down to 320 right now.
Absolutely.
The caustic soda removes 91% of the carbon dioxide from the air in just 6 minutes.
There's no technical question you can scrub CO2 out of the air. People have done it in the 50s for various reasons when they needed CO2-free air.
NASA uses similar technology to scrub CO2 from the space shuttle's recirculating air supply. But scrubbing air from a small, contained spacecraft is relatively simple. Cleaning the atmosphere poses a colossal problem for Professor Keith. His machines may create more CO2 than they can remove from the air.
It's that footprint measure that's one of the crucial things that drives the cost.
So the distance here between, if you like,
Keith and the Discovery team have to find a way to scrub carbon from the air at levels high enough to justify using the machines in the first place.
I mean, the fact is, we're beginning to do engineering. We've got some really exciting ideas that seem to suggest that we could do it much cheaper. But when you do engineering, you never know what's going to bite you.
The main feature of the scrubber they're planning is a 6-meter tower. Caustic soda will be pumped in the top, while air is blown in the base. When the two meet, the caustic soda reacts with carbon dioxide, trapping it. The big innovation is a honeycomb of thin metal packing inside the tower. It slows the flow of caustic soda, helping it absorb more carbon dioxide and boosting efficiency. To test the concept, Jen and Frank build a scale model. They need to find out if this miniature scrubber is efficient enough to wipe out its own carbon footprint. It's a huge hurdle the team must overcome if this technology is ever to work.
So that's 3,000% higher than we hope to do in the big picture.
So that doesn't sound like this is working well.
Many scientists now believe if we don't lower carbon dioxide levels dramatically by the year 2050, global warming will spiral completely out of control. For Professor David Keith, geoengineering could help prevent the worst.
Geoengineering is something we study to have on the shelf in case we find that even when we cut emissions, we still have enough CO2 in the air that we have a serious climate problem.
Keith's solution is a global system of industrial scrubber farms to capture CO2 from the air. Eco-engineer Jennifer Languel is working with Frank Zeeman to build a model of the scrubber machine.
Can we pull these off and start the pumps?
Yeah, let's start the pumps.
Okay, great.
Yeah, let's just watch that.
If that overall efficiency isn't where we need it to be, this experiment is pretty much useless.
Okay.
Okay, so we have
The results come quickly, and they're not good.
So that's 3,000% higher than we hope to do in the big picture.
So that doesn't sound like this is working well.
No, this isn't working very well at all.
The machine is using 30 times too much power.
This is saying right now that we're actually producing more CO2 than we're taking out.
Yeah.
I don't want to scale something up that we don't have operating at an optimal efficiency. I'd like to try and troubleshoot some of these problems before we try and scale something up.